All right, this is the last video for lesson 3, and for those of you who stay to the end, I'll give you a little surprise. Anyway, let's say a person this is for LOL diagrams. Let's say a person is on a diving board and they jump off and it ends with a perfect dive. So this is my quick drawing. There's one person at the diving board getting ready to jump off. Here's the water, and then he jumped off, landed on the water with a perfect 10 out of 10. So if you go to I also sent this one, the LOL diagrams of notes of when to rewrite it, what to write, when do we do it, how to write it, and how to do a formula. I'm gonna be doing these steps individually to show you how to do an LOL diagram. You won't have to do these steps individually if you do it by hand, or especially not in a computer, but I'm just doing this so I can go through it more simply. So this is a diving board case. So what do we write? So you can see that it's called LOL diagrams because there's this L for this chart, the O, and L. The first one I said is you set up the diagrams. Basically, here's the amount of energy, and we have kinetic energy here, potential energy here. This is where going to be our system, which we'll go over soon. And this is another L for the other energies. So the first part is we just write down, we just set it up. So when do we write? From this point, we're going to do now the initial and final case, and then the different points, the different parts of a system. So we write down the points based on when the situation happens. So for the initial case, that's before the person jumps out the diving board. The final case is after. And then I wrote down a list of potential materials that can be, or objects that can be part of the system. There's a person, the water, the board itself, and the earth itself because of the gravity. Okay. Then how do we write? I wrote down here that we need to determine the energies and the amount, just can approximate it. And then what objects affect the energy transfer? So here, I actually put the amount. I just estimated to 100 joules. And I put 100 joules for having PEI. So the potential energy initial case, it's only 100 joules and there's no kinetic energy. The reason why there's no kinetic energy is because the person is not moving at all. They're just getting ready to jump, and they're just standing there right now, but they have the potential to have all this energy when they jump. Then I put the 3 things that are most important for the system, which is the person, the water, and then the earth itself with its gravity. Then for this case, for the final case, kinetic energy is all the way to 100, and potential energy is 0, because at this point, he already landed to the water, so he already had the max amount of kinetic energy at that point. So there will be no potential energy to fall anymore. That's why I put 0 for PEF, and why I put 0 for KEI is because, like I said, it's not moving at all, so we're just leaving it in this case. So for how do we write? We write down basically the amount of energies are per system are in the initial and final case, and then the things that are present in the system. In actual problems, I'll just give you actual numbers, like saying, oh, the potential energy at this case in the beginning is 500 joules or something like that. But for this case, I'm just showing you how it is. And we can also do this qualitatively. That means even I don't give you a number, you know when someone's standing on top of a diving board or about to fall off, but not falling yet, they have potential energy, but no kinetic energy. So most of the time, I'll actually give you numbers to plot. All right, the final part is equations. This one, you do the sum of the energies for each initial and final case. So the initial case, there's just KEI and PEI. The final case is KEF and PEF. The initial kinetic energy and final kinetic energy, and the initial potential energy and final potential energy. We mentioned before that the initial kinetic energy is 0 and the final potential energy is 0. So you can just cancel those out. So that leaves you with this. The final equation is PEI, potential energy initial, equals kinetic energy final. In this case, I gave you the total amounts, and also during the assignment, I'll give you the total amounts, but later next week, I'm actually gonna make you solve for potential energy and kinetic energy with the LOL diagrams. So you're gonna have to do this equation with also solving KE and PE, because the velocity might change or the height might change. All right, summarize the whole thing for a LOL diagram. If you just know all the steps right away, you can just skip to this part. Here you draw the LOL. You can write down the potential energy, the amount of energy for each. So potential here, kinetic energy here. They're both 100, and then this is a system. So the only equation is PEI equals KEF, and then remember energy must be conserved. So when we check that 100 equals 100, that's right. So that means energy is conserved. If you don't get the same numbers, you may have done something wrong. All right. You should have an assignment to do a practice LOL diagrams. You're going to be given a scenario, and then there's going to be an assignment. You can actually modify the chart to estimate what the energies will be in an initial case and a final case. It'll make more sense when you see it, but make sure you work on that. All right. And I did promise a surprise, so let me actually do that. I'm actually going to show you my dog for right now. So give me maybe a minute or so. So here's my dog Simba. Here he is. So for those of you that watch to the end, you get to see my little dog. Right. Bye.